All right, in this video, we're going to talk about programs, processors, and languages. A program is just a collection of instructions that performs a specific task when executed by a computer. Programs are usually written by a programmer in a programming language, and then the instructions are carried out by the central processing unit or CPU. So, if you are not familiar with what a CPU looks like, it is a chip that looks like this. This is kind of like a cover on it. If you crack that cover off, then it kind of looks like this here. And it's just a very complicated circuit, really, is what it is. So that's essentially the brain of the computer. That fits into what's called a motherboard and in this little slot right here. So you can see there's like a little square thing. So that's will lift up, and then the chip can be seated down into this, and this cover will be placed over it. And generally, there'll be some cooling apparatus on top of that. Here you can see, here's the motherboard here inside of a case, and then the chip is underneath this fan right here. As the instructions are getting carried out by the CPU, it heats up and generates some heat, and so it has to be cooled down. Um, so that's what it looks like. The issue is that the processor only understands instructions written in machine language, and machine language instructions consist entirely of zeros and ones. So here is an example of how that might look. Here you have some code in machine language. It's nothing but a bunch of zeros and ones over here. Uh, Over on the leftmost column, what we have are basically these instructions written in a more compact form using base 16 numbers. I'm not going to go into a ton of detail about how that works. The main thing to remember for our purposes really is that really this is all that the processor can understand. It can't understand the programs that you type into it. Okay, there has to be some kind of translation. So lower level languages, those are languages that are designed with the computer in mind. Machine language, which I just showed you, which consists of nothing more than zeros and ones. Assembly language is another example. Um, so here are some assembly language instructions here. And bytecode, that's from Java. That's the dot class files from Java. One thing about low-level languages is that they are hardware dependent, meaning that if you have some program that's in machine language or assembly language or bytecode on one type of machine, then it may not run on another type of machine. So that's an issue. High-level languages are languages that are designed with, they should say, people in mind, right? Not the computer. So examples are Java, COBOL, Python, and um, any other of the languages that you probably have heard of. So high level languages have to be translated into machine language before they can run, right? Only humans don't really want to deal with machine language, but that is the only language that the CPU can understand. Humans would rather program in a high level language. It's just easier for humans to do that. And so there has to be some translation process involved. So that program translation is done by another program, usually a program called a compiler or an interpreter. There is an important difference between compilers and interpreters. So a compiler would translate the entire source code at once and then ship all of the machine language instructions to the processor. So that would be similar to how, say, somebody would translate a book, where you have a book written in one language, and then somebody would take that book and then translate it into a different language, and then just release the book, the whole book, as a translation. An interpreter will translate the source code line by line, or almost line by line, in small chunks basically, and then it'll do the translation and then ship those instructions, those machine language instructions, to the processor. And then alternate back and forth. And that's similar to, say, how an interview would be conducted through a translator, right? The person conducting the interview would ask the person who's being interviewed a question that would be translated by the interpreter. Then they would answer the question and interpret a little bit more, and then ask another question and interpret a little bit more. So small chunks of code are translated and then sent off to the processor, and then that cycle is kind of repeated over and over again. So the main thing to know about Python is that it's usually interpreted. So I personally haven't ever seen a Python compiler, but that doesn't mean that there's not one out there, I suppose. Python is interpreted, and that kind of allows for a little bit more flexibility than maybe a compiled language would be. We've already seen the interactive shell, where you can type in commands and they can get executed. So that is usually a feature of a language that's interpreted, like Python.